So actually, the last time I was in Barcelona was 7 years ago, and we were working on a collaborative platform called Peer-to-Peer University, which was kind of forming study groups around open educational resources before the MOOCs came along. So I actually just Googled it today, and I found we were even in El País. I didn't even know that. So that's kind of cool. So I've been interested in facilitating collaborative learning for a long time. And in my PhD thesis, I did two studies. We had a university course, 4 teachers. I was in the educational faculty, that had been going for many years as a small seminar, 25 students, where my supervisor was really using a lot of wikis, a lot of wanted to create knowledge community, having students contribute their ideas to inquiry learning. And then because of a program change, suddenly we were going to have 85 students. And so it's not yet massive, but 25 to 85 is a different dimension. So the question was, do we give up and just give lectures, which is the default choice, or can we actually do something really interesting where we maintain as much time as possible in small groups, collaborating, sharing ideas, and in that case, we need a more specific pedagogical script, and we need some technology to help us orchestrate, to help move things around. So my previous supervisor, Jim Slada, he developed this model called the knowledge community inquiry model, which he has used in a lot of actually high school classes, secondary school classes, and some university classes, which is really formed around this idea of a knowledge community. So you want students to bring in their own ideas, you want them to be able to share them, but you also want that to be structured in a way that you're sure that they're meeting the learning goals. Right? It's not just let's all talk about whatever we're interested in. So it's kind of you have to gently guide them. You need to design the script, the prompts, but also the technology supports to ensure that you are able to. And typically, the way it works is that you work in small groups to do research on different topics according to templates, and then you have an inquiry project where you're compelled to look at all the stuff that was generated by all the other students, so that you, at the end of the class, actually know all the material, not just what you specialized in. So this first course that we did, it was an in-class course with some online components, but we designed these scripts, and I'm not going to talk too much about the scripts themselves and the theory. I'm happy to discuss later. But the main idea was that we would have these weekly themes, collaboration, mobile devices, tangible, ethics and teaching in the internet age. But then for each week, we would have this sequence of activities that were common, and so the weekly theme informed all of those activities, right? So they would have homework about collaboration, they would have a lecture about collaboration, short lecture, they would do presentations about technologies that they've researched that had to do with collaboration, they would discuss collaboration in their small groups, then they would work on a design. That was something that happened every week, that they kept working in small groups on developing a final project, where they would say, well, this week, let's think about collaboration, right? So it informed all of those things. And so I came up with this kind of, you don't have to look at all the details, but the idea is it's kind of a script matrix where you have these themes that impact all the activities of that week, but then you also have these activities that continue throughout the whole curriculum. And to me, that was kind of an interesting way of thinking about, how do you, because oftentimes we talk about scripts, we talk about one class or even 20 minutes. And so for me, I was thinking, if you have a 12-week class, how do you think about designing the curriculum in a scripted fashion, but where you do cover all of the topics and you interact in the ways that you want to interact? So how do we do it, right? And it was very ad hoc, kind of hacked together. But the way we did some of these things was basically using just Python and the APIs of some Open Web 2.0 tools, like Google. Here's one example of a little script we did in a class where they come back from internships. So the teachers, they're future teachers, so they spent the month working in a school, and they come back, so they have all these ideas, and we want them to reflect upon them. So we said, okay, here's a form. Fill in one ethical question that you met. And then we get a spreadsheet. Then we have a Python that scrapes the spreadsheet and generates a list of links on the right. And then people click on those links and they have wiki pages, right? So just a bunch of Python scripts that do things. Very specialized, very, it worked once and that was enough. But it worked, and it let us try out the scripts and the theory. Then the second design study was doing a MOOC. And this was kind of based on the same course content, but redesigned for a different population. This was teachers already in schools, so professional development for teachers. And we ran it on edX, and in this case, we didn't know how many people we would get, but let's say we get 1,000, a few thousand. Suddenly, again, your scripts have to be more carefully thought through, and your technology has to be a lot more robust. And you have all the constraints of working in the MOOC environment, right? So initially, just thinking about the scripts, we kind of came up with two different ways of thinking about scripting at scale. Some of the things we do kind of, I don't have a good term for this. If you have, feel free to suggest it, but despite of scale. So basically, we want to enable the things that are really rich about small group learning, even though we have thousands of people. So we still wanted people to be in small groups and work on this design project, because that was one of the richest aspects of the previous course. And to have this kind of artifact that you keep adding to week by week, and each different theme contributes to the content, and as the weeks go by, the prompts become more sophisticated. Right? So the first week we say, what's your target group? What's your learning, what do you want to teach them? And in week 5, we're talking evaluation, assessment, equity, right? Really deep topics. But doing, persistent small teams in MOOCs is very difficult for many different reasons. But we still wanted to try. So we built this collaborative workbench environment, where basically the idea was to give groups everything that they needed in one space, so they wouldn't be confused. So you see here they have a chat, a persistent chat with all the people in the group. You can see who's logged in or not. You can't, it's zoomed out, but there's a little green thing, so you see who else is online. We have these different tabs. So the first tab is the welcome tab, and that has the weekly prompts. So in week 3, it was like, hey, this week we're working on collaboration. Take a look at your design. So this would be the same thing as we would do in the class, where we say, yeah. But then we had an Etherpad, it's a collaborative editing like Google Docs, where they could take notes and stuff. And again, they had a new one each week with new prompts. So maybe 3 questions that they could start their discussion each week related to the theme. We had a wiki, which would be kind of where they edited the final product. And the wiki was always exposed to the world, the MOOC world. So other students could come in and do peer review and stuff like that on the wiki, whereas the chat and the Etherpad was their private space. We also added some more social features. So you have the chat on the left. We added an email functionality that was anonymous, but kind of a mailing list within the group. We had some notifications so that people could, because we found that people being online at the same time was really important for collaboration. So people would just get an email whenever someone else joined their group, and with a link that took them directly to the collaborative workbench. They didn't have to go to edX, log in, click a link. And that was used quite a lot, and that was really actually quite important. So that was kind of, despite of, we could have done this with 20 people, but the cool thing is that we were able to still do it with 2,000 people. On the other hand, there are some scripts that we can do because of scale, because we have 2,000 teachers. There are things that we can do that we couldn't do or couldn't do as well with 20. So like crowdsourcing. Because doing the design group it's a big commitment, and it was optional. You could go through the whole MOOC without actually building a design. You would still get your certificate of accomplishment. But we still wanted to harness people's ideas and experiences. So, for example, in the first week, we said, can you suggest some resources that you know about in your field? Okay, you're a physics teacher. You know that there's a really good simulation. Type it in. It takes you 2 minutes. And then, by the way, can you go and look at 3 other resources suggested by, and we can give you the resources suggested by physics teachers, because we know each student has some tags and so on. And you can rate them, you can comment about how you would use this in class. Again, we've asked you 5-10 minutes of your time. It's not high commitment, but because we have 2,000 people, Now we have, a database of 2,000 resources, semantically tagged, rated. We have tag clouds and so on, which is really valuable, and which we now can feed into the design groups. So when the design groups come in week 1 and they start thinking about what kind of design, we're feeding in all these resources from the crowd to help them, again, selecting the physics resources to the physics teachers because we know who they are. So you don't have to look at the details here, but the idea was to kind of map out, again, at the bottom you have the weekly themes that inform all of the scripts, but then you have these kind of interdependencies between, so for example, at the bottom you have the design groups that keep working on their designs, but then the designs circulate up to the rest of the community every week for constructive feedback. So we didn't care about grading them because A, they're not done, B, we don't think it's that accurate, and C, it's not even that interesting. What's interesting is how can this become better? And especially, again, this week you watched videos, because it's a MOOC, you watched videos about collaboration, you did a reflection, you talked about it in the discussion forums. Now look at this in-progress lesson design. How can they incorporate more collaboration, right? So I think this way of designing a script for this kind of a class was really interesting and was quite effective. We also, so the way we did this was actually using LTI, which is a way of enabling external resources hosted on our own server, kind of embedded into edX. So here you see an example of the edX interface, as you know, with an activity that we created from scratch. This is actually a live meeting where we use Google Hangout, but we add, on the left there's an open chat. On the right, there's kind of, I don't know if you've seen Google Moderator, but it was this simple tool where you could post a question and people could vote up the question. And so it's the same thing, because if you just had the chat, it's very hard for the person speaking to keep an eye on the chat or the Twitter feed. But in this case, the chat can be kind of, the group can chat away, but then if they want to ask a question, they post it on the right, they can vote it up, and the person giving the presentation can always see the top one. And then once he's answered it, or if he said he doesn't want to answer it, he can just archive it, and the next one comes up. And this interface worked really well. You also see how nice it is that we're not asking students to leave edX and go to an external platform where they might get lost or not come back. We're really, this is, so they do a video, they do a quiz, suddenly there's an LTI thing asking you about some interesting resources, then you do another quiz. It's fully integrated into the workflow. And the technology structure, again, you don't need all the details, this is in my thesis, but the idea was that we have all these individual LTI components that would be one screen with no menu system, no login, no nothing. But because they were all served from the same server and backed by the same database, we could do really rich things because the only thing we got from edX was a persistent identifier, right? We didn't get any personal student information. But because that was the same identifier, the first time the students accessed, we could ask them, are you a physics teacher, a math teacher? What age group do you teach? What are your interests? And then next time they log in, we know that they're a physics teacher because it's the same ID. And then they say, oh, I want to join this group. So next time they go to the collaborative workbench, we know which group they're in. So we were able to do this really rich thing that if you had 10 different LTI components, because the LTI framework doesn't allow this rich data transfer, we would not be able to do. Sorry, I'm talking very fast. Is there any questions so far? And my thesis is also available if you want to really dig into the details. All the source code as well, but it's I wouldn't recommend using it. You could look at it if you want. So, one thing is talking about the script, and there's all kinds of interesting things you can talk about there and how we could improve it. But a key problem is the technology, because I've talked about this to other people. Like they're actually in EPFL, there's a group of librarians who want to make a MOOC on data management for researchers. And they said this model would really fit nicely because you have physics researchers and social science researchers, and they have different interests, so it would be nice if we could group them. But then some of their ideas, we actually want them to kind of bubble up and across. And they have lots of experience, we want them to contribute ideas, and maybe the boundary project could be like a data management plan, and they could kind of really map this nicely. But how? Right? Unless you have a programmer for 3 months working full time, because basically what I did, I wrote, this was basically one script written, if they submit this resource, then show this component. It wasn't a framework. So it would be quite difficult to adapt this to something else. So that's one problem. Another thing, the data analysis of this, I think has a lot more potential for being interesting than analyzing data from a traditional MOOC, because basically in a traditional MOOC you have such a small opportunity space. All you do at any one point is, should I watch another video, or should I watch the same video again, or should I go to the discussion forum? Whereas here you have these complex behaviors of interacting in groups and submitting reviews and receiving reviews and acting upon them. But of course it's hard because it's very diverse data and it's hard to kind of match it, think about how you can analyze it. It's very time demanding. So at the same time as I'm working on this, I come across Pierre Dillenberg's work on orchestration graphs. And he wrote this book, which I'm happy to share with any of you if you want it, where he kind of lays out this vision of orchestration graphs, which I'll briefly present to you, and then I'll talk about what we did with that vision. So orchestration graph starts out as an educational modeling language, which there have been many attempts at making. And it's interesting looking at these different languages because they all make different elements salient, right? In this case, the two things that are the most salient is the time dimension, which is the x-axis, so you see the sequence of things, and it's the social planes. So it has these three social planes: individual activities, team activities, and class activities. Of course, each of these activities have lots of metadata, so you can encode other things, but those are not visually things that spring to your mind. So I mean, that's one interesting way of collaborating, comparing educational modeling languages. Now, in this case, you have a small collaborative script, and this is called ArgueGraph, which some of you might be familiar with. So the idea is you have a questionnaire, and you ask people, for example, how do you feel about athletes doping, performance-enhancing drugs? And the point is that people could be for or against it, but they could be for or against it for different reasons. Maybe it's because you're concerned about people's health. Maybe you're concerned about the fairness of the game. So you encode this questionnaire, almost like the one you have in the teenage magazines, like what kind of a person are you? And you come up with this two-dimensional representation of people's ideas about this specific topic. And then what you want to do in this case is you want to maximize the distance between each pair of students because the theory is that will lead to more interesting team discussions, right? You create this kind of artificial conflict. And then you go into the second activity, which is, okay, now you're two people, but you have to give one answer. So you have to fight it out and try to convince each other. In the end, you have to submit a single answer. And that's where a lot of the interesting stuff happens. And then in the end, the teacher has some statistics, and he can do a debrief, and he can say, well, look, who moved across, who changed their opinions and why, and so on. So this is a graph that he's been using for many, many years. So you have these activities on these planes with this time axis. Then you have these operators. And this is kind of from a data flow perspective, so that in the questionnaire, you generate some data for each student. Then you have an operator that generates this map and selects the maximum distance, and maybe even generates a nice visual map for the teacher to do in the debrief. And so you have this flow of data and this transformation of data. And in his book, he has a whole library of them. But you can also have between the activities pedagogical edges, where you really say, like, what is the relationship between A1 and A2, right? Is A1 a prerequisite for A2? Is it motivation, right? Is A2 a more specific example of a general principle? Or is it induction, where you go from a specific example and, right? So this is really trying to tease out and make explicit the pedagogical structure of the class, of the script. And you can have, things like you split based on, so you have an operator that distributes people, and then you have half of them watch a text description of something. But actually the test, some of them take a text test, some of them take a schema-based test, Then they watch a video, then there's a group formation, then you match the people who did the different things. So here's the video that they're watching. Here's the concept map that they construct together. And you can start, the idea is really that when you're running this graph, what you have is a computer-readable description of the pedagogy, the pedagogical intent. And if you can now start to map the learning analytics back onto this graph, the idea is that you can start coming up with much more interesting analysis and potentially even optimize the graph itself, adaptive learning, all that kind of stuff. So you start adding weights and you say, what is the to what extent does A1 predict a success in A2? And for example, you can look at this from different perspectives. One of them is if you have a graph that's been run a number of times and you know that A1 is not very predictive of A2, doesn't mean A1 is useless, right? But it means that if you're in a real classroom, because Pierre is really concerned about in real life things happen, right? These graphs are very perfect, but then you try to run them in a real classroom. So what if a fire truck comes past the window and all your fifth graders are really focused on that for 5 minutes? You now have 5 minutes less. Can you cut activity A1? Well, if A1 is to very slow, it has a very low predictability, for A2, then yes, you can, right? Because it's okay. But if A1 is input ideas and A2 is sort them, or A1 is learn the principle and A2 is apply it, then you have to cut somewhere else. So I'm going to skip through this. And the final thing I'll say about this is that he has this metaphor in his book, which I found really spoke to me. So imagine, and we're from Switzerland, at least we're in Switzerland, and so we talk a lot about mountains. So if you imagine that you have a mountain, and you put these weather sensors at different places in the mountain because you want to model the weather phenomena. And these sensors, they stream live data, so that's great. You can do all kinds of analytics around these data. Maybe you make a machine learning model that predicts the weather based on something, right? However, unless you have a 3D model of the mountain and on that 3D model indicated where the sensors are located that you're getting the data from, that data is useless. And this is kind of what we're doing with MOOCs right now. At EPFL, we have data from 60 MOOCs that are all in one database. That there's a lot of work that's been done to normalize the data, even from Coursera and edX, and to make sure that you can actually do one query on 60 MOOCs in one line of code, which is deceptive because it makes people write, and I'm not picking on EPFL, but it makes people write papers saying that across 60 MOOCs and 20 million events, people who pause the video twice are 5% more likely to not drop out than people who didn't pause it, okay? Which is meaningless because we don't know what the course was. I mean, in the University of Toronto, we had courses on Python and we had courses on Aboriginal education. And those instructors had very different beliefs about what learning looks like, about what student success looks like. The videos had very different purposes. And even in the same course, the video teaching you how to install R is going to be different from the video where you are teaching someone second-degree equations. So that's kind of to me, something that's very motivating about this kind of way of thinking. Now, there's two elements to this which are really interesting, which I'm kind of going to not talk much about. One is the orchestration graphs as an educational modeling language, the whole idea of teachers using this to share designs, repositories, collaboration, and stuff like that, which I know you guys are very interested in. That's something we are also interested in, but I'm not going to mention that much more. Hopefully we'll have more time to explore that in the future. The other thing is the analytics part that I talked about. That's super interesting to us, but we're just getting started, so I don't have much to report yet. I'd love to discuss with you guys. I'm going to talk mostly now about what we're actually building, which is really focusing on, can we take these orchestration graphs and run them? So in other words, could someone who saw my presentation about my PhD thesis design a MOOC in a graphical interface without being a programmer and actually run the MOOC? And how do we build that infrastructure? So when we started, we have this book, with all these growing and all this theory and stuff like that, and we're basically trying to build it. And of course, when you try to build something, you realize that, this isn't really, it says, well, then the student data arrives here. But how does it arrive here? And how exactly does it look like? And what, there's a lot of kind of magic that when you're writing something in code has to be very specific. And there are some things in the theory which don't actually work in when we're trying to implement it. So there's been a really interesting kind of back and forth between us trying to come up with an architecture and the theory. So for example, initially we had these really nice edges, each activity is connected to the next activity. And as we were working on this, we realized that we need kind of to have a data flow layer where the links are much more flexible, because we want the data to be able to flow not just to the next activity, but to multiple activities. And we want, for example, data to go to one operator and then possibly to another operator. So above you kind of see, this is the same graph, but on the top you kind of see a data flow visualization of how data is flowing and social grouping and stuff like that. And on the bottom, you still see the same graph where you have the pedagogical edges and you can put on the learning analytics and stuff like that. And this is how it actually looks right now. This is not ready for it's not ready for public consumption. It's in very rapid development, but this is what we have right now. So this is the graph editor. So for example, in this case, you would say, well, I'm going to have, as a teacher, I'm going to have an introduction. Then there's going to be an individual quiz, and you see there's a link there to a social operator that takes the results of the individual quizzes and group students, and then the groups go to do a collaborative quiz on the second line, and then maybe they're back to individual for some assignment, and then there's a conclusion with the teacher, and the teacher gets access to the data from the individual quiz and from the individual work, so he can do a debrief. So this is just a simple, script. And so you add activities, you add operators, and then you select an activity, and you have a bunch of activity types. So you have quiz, collaborative quiz, video player, and these are fully extensible and pluggable, which I'll talk a little bit about, the operators as well. And then you can configure them. As you see here, I'm configuring a collaborative quiz. Okay, so this works. This is more or less real. I'll happy to show you live later. And then, just to get you a sense of what it looks like, and it's kind of hard to simulate learning at scale. So this is me using actually 4 different browsers because it has cookies, which is annoying. I'm going to actually change that to make it easier to test. But right now I have to use 4 different browsers to be logged in as 4 different students. So imagine you have the teacher on the top left that has designed the graph. And right now the actual interface for running the graphs is needs work, but it'll come. And then you have 3 students who are logged in and they're waiting for the teacher to let them go. So the first activity is a video. So the teacher clicks, run first activity, and it starts playing the video in the student's browser. Then on the teacher screen there, you see a dashboard. And the interesting thing is we have all these activities that are very different. So the data they generate will be very different. So we want to have different kinds of dashboards that are, we don't want to just know how many students dropped out. We want to see what they're actually doing. So in this case, you actually see 3 bars showing the videos that are being played. You can see here that someone's jumped ahead. You can see that someone paused the video, and that color slowly changes to depending on how long they've paused the video. So that you can see at a glance, oh, this guy's been pausing the video for 5 minutes. Maybe I should check on him, or maybe he went to the bathroom. So this is just a prototype. We haven't, it was just to see what kind of things we could do fairly easily with the data we get in. And then if you have a collaborative editing task, there would be a different kinds of dashboard. So the dashboards are also pluggable. So the next activity is a simple form. And in this case, the operator simply groups students based on students who typed exactly the same thing. So no pedagogical utility, just a way of prototyping that data actually moves through the system. So in this case, the question is, do you agree? And 2 of the students agree, and 1 does not. Okay. And the 2 students on the right, they agreed, so they are now in the collaborative activity, which comes next. They are now in the same group. And so they have a collaborative form, which gives them a chat, and also they can collaboratively edit the form. Whereas the student at the bottom there, he is alone, and he hopes that he had one of Ishari's simulated students to chat with, but that we leave that for future work. So that was a social operator that took some data and generated groups. Now is an example of a product operator that takes some data and generates other data. So in this case, they're doing some brainstorming about sustainable development. So they have a form where they can submit multiple times, and then they can say when they're done. And then you can put that in, and you can say, I just want a list of all the student ideas. That's a really simple operator. So then you can anonymize it or not, that's a configuration. But you can also take exactly the same data and feed it into kind of a concept mapping tool where students can drag activities and say, you know, put all the ones that has to do with energy on the left and so on. So the idea is just to show you that, you know, we have these activities, we have these operators, and the idea is really to be able to plug them to the extent possible. And you'll never be able to get a concept map into a video player unless you have an operator in the middle that does some machine learning and searches YouTube for the most appropriate video URL and then feeds it into the video player. But the idea is that they should be able to combine these in ways that we had not predicted. Tiny bit about the technology for those who are interested. It's all written in JavaScript with React and Meteor. We're really trying to make this as modular as possible because the vision is for this to be an ecosystem. And for this to be a long living project, not just something that we're doing for paper and then we put it away. All the code is open on GitHub right now, okay? And I can get it running on your laptop in 5 minutes, seriously. And I'm happy to do so if anyone wants to play with it. So the idea is that the activities and the operators are separate JavaScript packages on NPM. They're actually not on NPM yet, but they could be. And that you could add a new activity or a new operator by publishing your own package to NPM, and someone else could do npm install AC, you know, virtual world, or op machine learning groups, and use it right away, as long as it fulfills the API. So the point is, yes, you need to write right now in React and JavaScript. I'll come back to that, but you don't need to know anything about our code other than this is the API. So I'm not going to go into this. I'll show you this if you're interested later. But just to give you a sense, right now, this is the entire code for the video player, okay? So you have some metadata, and this is what makes it show up in the list. So if you add this package, how does it know it's a video player? Because it says there, and so when you see here are the activities available to you in the editor, say video player. That's where it comes from. This, which actually most of the code, is defining the properties it needs to be initialized or instantiated. So when you add a video player to the editor, it will say, what's the URL? Because it's a video player. If it's a quiz, it will say, which questions do you want to ask? And so on. And this is the actual code. And of course, here I'm cheating because I'm using an existing library for playing videos. But that's the point. Like, you know, we're trying to make writing these new activities as easy as possible because we really want to see people experimenting and doing really exciting stuff about that and not getting bogged down in boring detail. Same thing with, so this is the dashboard. This is the entire code for the video dashboard. So if you want to have a live word cloud of someone editing a collaborative document, you know, you can do that without much code. This is the entire code for the operator that groups people based on typing exactly the same thing. So again, it's a very stupid algorithm, but the point is, you know, the length of this should be proportional to the complexity of your algorithm, not to anything else. So very quick about some of the things we're doing. This is, so future work could be really long. This is like future work within the next 12 months, like immediate future work, hopefully. So we want to make it even easier to build really rich collaborative activities. So we're trying to kind of offload a lot of the complex stuff that many activities need, like collaborative editing. Traditionally, that's quite hard to do, and typically the way to do it would be to use Google Docs or Etherpad, but then you lose a lot of control, and it's hard to integrate properly. So right now, the way we're doing it is very naive, but we have a bachelor student working on this to build proper collaborative editing into our engine with patching and diffing and stuff like that, which will work. So we will have a rich text editor for writing essays together. We'll have a code editor for doing collaborative JavaScript coding, whatever. But we'll also have collaboratively editable forms, which I've actually never seen before. So you can type, I can type, and it's just like in Google Docs, except they're forms. So we can structure it much more nicely, and we can take the data and combine them much more nicely than if you try to scrape a Google Doc. We want to add voice and video conversation. Again, not using Skype or something, but I think with WebRTC, now we can actually build that into our platform in quite a nice way. So that would be super nice that any activity could just add a, chat with your partner, and it's there. And we want to add this ability to do compound activities, because what we found is when you're doing a collaborative activity especially, often you want to have a chat on the side, or you want to have a video call, or you want to have a concept map, but then you want to have a little text field that says what the concept map is about, and you want to have the notes from your previous activity. So the idea is if we can take these individual activities and kind of let the teacher create a layout, something like this, where they combine them, and my work with the collaborative workbench for my PhD thesis also informed my thinking here, where you have these different components and you put them together. So that's the activities. But so far, I talked about activities that still live on our server, right? So they're very well isolated. The code is quite easy to write, but you still have to write it in JavaScript and React. You don't have to worry about Meteor because we abstract that. And you have to npm install something and so on. But the idea is that it should also be possible to have activities running on other servers, where you can write it in any programming language you want. You can have any kind of server backend that does complex processing, whatever. And I looked around to find existing frameworks for embedding activities, like SCORM, IMSLD, LTI, everything. And so we have this paper at the bottom there, which is in Learning at Scale, as a work in progress. But there we came up with 4 things that are missing from the activity definitions that we've seen so far. Basically what we want, if we have a concept map activity, we want to be able to put data in. So if you've had a form where you brainstormed something, we want to be able to take that data and pre-populate the concept map. We want to get streaming learning analytics. So while people are working on the concept map, we want to know what they're up to, so we can do the dashboard so the teacher can know live whether students are doing well or not, which informs the fact that the teacher should be able to do some kind of orchestration. Okay? We're still defining what that means. I mean, the simplest thing is just press pause. If you're in a classroom and say, okay guys, right? But it could mean repairing groups because people have been dropping out. It could mean saying, well, this is not working, so I'm going to skip to the next activity sooner, or I need to do a little video lesson because everyone's failing, whatever. And finally, when the activity is over, we need to get the data, the product that the students generated in some kind of a format, at least some JSON. I mean, again, you cannot just put a concept map into video, but if you have some JSON format, then you can always have an operator that does something with it and generates what you need. So we haven't found that anywhere, and if I'm wrong, let me know. But the idea is, if we can't find that, let's try to come up with it. Maybe that's hubris, but someone has to start. So we want to define an external protocol for activities and for operators. And this is a direct link to work by your group, because I read Ishari's master thesis. I found it really interesting. And when I saw this table of all the different people who've come up with machine learning approaches to grouping people, I'm like, each of these papers should be an operator that I can just install or link to if it's running on an external server. It could be written in COBOL, I don't care. As long as it has a API that I can send my students and the data it needs and get back to groupings. And hopefully we'll at least attempt to do that with Ishari's algorithm, which I think would be really exciting. But this could also go the other way. As I said, so we call actually frog, we call this thing frog for now for various reasons. But as I was saying, you have these frog activities, they can't actually live by themselves because they're relying on all these really rich APIs given by the frog kernel. But one interesting thing would be to say that, what if frog could act in kind of headless mode in just serving up these activities? So if you had a system that could consume activities using this protocol, then we could have a frog engine running the collaborative concept map and exposing it so that you could use that in your system, and you would get the collaborative editing and you would get all of those things. And again, we think that would be super exciting if anyone had this, so if we could integrate it with ILD or anything out there, something to think about. how do we, so there's all kinds of issues about, so far I kind of talked mostly about in a classroom in a synchronous setting where everyone moves in lockstep. There's lots of issues about how do we make this asynchronous, which I'll get back to. But one of the things is how do you integrate this with a MOOC, okay? Because we're doing a MOOC. And we don't want to run the whole MOOC on our platform necessarily. So one of the ideas I have, one idea of course would be to just have a single LTI window that's a window onto the engine, and through there everything happens. And I actually think there's more scope for live things in MOOCs than people have been trying so far, and I would love to try that, to say, you know, Thursday at 12 o'clock, log on, and you're going to be doing a sequence of activities. And maybe it's every Thursday, maybe it's every day at 12 o'clock, and whoever comes, I don't know. So that's one approach. But another approach is to say, if you have a graph, and you right-click on any activity, you get the LTI URL for that activity. And so you could take kind of the graph and almost like drag it apart and say, okay, I'm going to put this activity here, and then I'm going to have a quiz, and I'm going to have video, and then they go to the form. And next week, I'm going to embed this other activity. But at the back end, they're all served by the same engine, and so you have still the configurability, the data flow, the dashboards, all of the nice things that you get from Frog. So this is just an idea, but. So analytics, we're very interested in. Coming back to also the open data standards, right? How can we, we're getting all this data that looks so different. We want to have it so that people can write dashboards, so we can do really interesting things with it. We have different granularity. One of the things I'm worried about is actually very high density, or what do you want to call it, data. So we are doing eye tracking. Okay, that's terabytes of data per student. So the traditional way of saying, here's an event, and I'm going to write a string to the database for that event, doesn't work. But is there any way in which eye tracking data could be normalized, or does it always have to be a special case, right? People are doing EEG tracking now. But even if you just track the mouse cursor, or track every single keystroke as people are doing collaborative editing, which is not ridiculous, because being able to reconstruct the way in which people collaboratively edit is super interesting. So that's not something silly. That's a very concrete example. But again, generating for example, an XAPI event for each keystroke seems insane. So that's something I'm still really working on. Dealing with synchronous and asynchronous scripts, timing issues, time elasticity. I could talk more about this. The final thing I think is one of the interesting design things here is that we're trying to build this framework where teachers or instructional designers can kind of design almost anything. I mean, there will always be limits, but we want to make it as configurable as possible. But there's kind of an interesting design choice between how configurable do you make an activity? When do you make two activities? Right? Do you have form with text answers and form with with radio buttons, form with multiple answers versus form that immediately gives you feedback, or do you have one form component that just has so many knobs and levers that you don't even know where to go? So that's a balance that we're kind of slowly just experimenting with, and same with operators. And finally, this fall, we are doing a MOOC. Pierre Dillenberg, the head of the MOOC factory at EPFL and the originator of the eMOOCs conference, is finally doing his own MOOC. The title right now is Instructional Design for Engineers. It might very well change. But there we want to, again, we don't want to run the whole thing on our platform for sure, but we want to at least try it out, have some activities where students interact with it, but possibly also have students use the back end. So use the editor to actually come up with their own graphs. And we're also planning in the fall a university lecture with 400 students in a big auditorium learning introduction to statistics, and we want to come up with some productive failure scripts. So we asked them, how would you represent variance in a data set? And then they draw and they try to discuss. And so we're thinking, how can we script that and how can we do it in a classroom? So right now we're thinking maybe focusing more on smartphones than on laptops. Maybe they're drawing on paper and taking pictures. And maybe we have some algorithm that is able to actually, this would be interesting, to recognize and group similar representations. Because if you have 200 groups and you have, again, it's live because they're in the classroom, is there something you can give to the teacher that they can do a debrief? So that stuff is happening. And I think that's all I have. Thank you very much.